Hello, good morning everyone. Myself Arjun Kumawat and I am going to deliver a demo lecture on the control system and the topic is time domain analysis. Right. So first, why we need to study the time domain analysis? हम पढ़ क्यों रहे टाइम डोमेन एनालिसिस के लिए? एग्जाम में आ रहा है वो एक अलग बात है, हम पढ़ते क्यों हैं? मान लीजिए अगर हम इसको एग्जाम्पल से समझें, इफ यू इन द ड्रग इंडस्ट्री, लेट अस से एक ड्रग इंडस्ट्री है और वो आप एक मेडिसिन डेवलप कर रही है, तो उसके इफेक्ट को एक पेशेंट्स पे, लाइक पेशेंट्स का ऑब्जेक्ट क्या हो सकते हैं आपके, रेट हो सकता है या फिर रेबिट हो सकता है या फिर मंकी हो सकता है, उस पे आप वो ट्रीटमेंट करते हैं एंड दे ऑब्जर्व द इफेक्ट ऑफ द मेडिसिन फॉर ए टाइम period like 1 month, 2 months, and they observe that what are the effect of the medicine are the on the object what we have, like monkey or the rabbit, right? In the similar fashion, if you want to observe the performance of a system, then you need to study the time analysis. That means to evaluate the performance of a system with respect to time, then we need to study the time domain analysis. In the time domain analysis, we have a response that I call CT. It contains two parts, that is transient part. This is transient part and the steady state part. Right? I denote as CTRT and CSS of T. This is my response of a system. It contains two parts, transient part as well as steady state part. Sometimes it is called force and natural response also. Now, how can we identify the transient part and the steady state part for a given response? Let us consider one example. 1 minus e raised to power minus et ut. It is my response. And if I want to know the transient part and the steady state part of this response. So for this, if at t approaches to infinity, as t approaches to infinity, the part going to vanish is called transient part. It's called transient part. That means at t equals to infinity, limit t approaches to infinity, the part going to be 0 is called the transient part. And here, if you are observed here, this is ut minus e at u of t. If I am going to put limit t approaches to infinity, it is 1, right? And it goes to be 0. So this part, that means this part is my transient part, or I just denote in the CTR form. This is my transient part, and the remaining part is called the steady state part. Clear hai yahan tak? How can we identify this steady state and the transient part for a given step or given response? Yeah. Now, this is the basic idea. Now, what are the transient response? What are the effect? What is the effect or why it is important? So, CTRT, that is transient part, it deal with the performance of a system, like if it is oscillatory or damped. This information can be given with the help of the transient response. Now what about the steady state response? It deal with the accuracy of system. That means it provide steady state error. It provide information regarding to the steady state error, right? So this is my transient response and the steady state response, and what they are using with the help of with respect to the time domain analysis. Now the next topic I'm going to cover is the first order system. The first order system, that means I'm just going to draw a block diagram for the first order system. This is 1 over ST, this is C of S, this is plus minus. I'm considering the unity feedback system, right? So closed loop transfer function can be written as Cs upon Rs. This can be 1 over St plus 1, right? For this open loop transfer function, the closed loop transfer function can be written as 1 over St plus 1 with, okay. So this is in the time domain, it is RT, in the time domain it is CT, and this is error signal I call ET. So ET is my error signal. This can be written as comparison of this minus this response, that is RT minus C of T. These two parameters are very important to discuss the time domain analysis, right? The first input I am going to apply here is my unit impulse response. The first one is unit impulse response. That means RT is delta of T. RT is delta of T. So in the Laplace Rs of Rs, then the Laplace of delta T is 1. So put this Rs is 1 here. So we got here 1 over St plus 1. Convert it into the standard form. This take T as a common. So this is 1 over 1 by St. So taking the inverse Laplace of Cs, we will get here 1 by T e raised to power minus T by T u of T. This is my impulse response for the first order system. Now my aim, okay, so first you can draw the impulse response CT. Impulse response CT, this is at t equals to 0, we have 1 by T, and as T increases, it decreases and goes to be 0. The responses look like this, right? So this is my impulse response for the first order system. Now I am going to consider the error signal for the first order system. I am erasing this value. So for error, what we have, ET again, this is difference of RT minus C of T. RT is my delta T, CT is 1 by T here, e raised to power minus T by T and u of T, right? Steady state error, what does the mean of steady state error? Steady state error means the error present in the system at t equals to infinity. Error present in the system at t equals to infinity is called steady state error. I denote as ESS, that is steady state error, that is limit t approaches to infinity E of t. This is limit t approaches to infinity delta t minus 1 by T e raised to power minus T by T and ut. Can we calculate this? Someone asked, okay, 0 minus this is 0 and steady state is 0, which is not correct. 0 minus 0 is not correct, because at infinity my input is not present. Whenever you are going to compare something, the one quantity should be present. That input is present. Input should be present. Here, input is only present at t equals to 0. At t equals to 0. It is not present at t equals to infinity. So you cannot compare this quantity and this quantity at infinity. So my steady state error for first order system is not defined. Right? At t equals to infinity, my input is not present, so we cannot compare the response. That's why we can say my steady state error for the first order system for impulse input is not defined. Clear hai? Okay, we are going to consider the second step response for the first order system. The second is step response. For the step response, RT is UT. So RS is simply 1 by S. Again, C of S is 1 by S and ST plus 1. So this can be written as this is. And partial fraction, this is y. So either we can take LCM and compare, or you can use the residual theorem. So this is for the residual theorem. I'm going to consider here 1 over ST plus 1 at S equals to 0, that is 1, and B is 1 over S at S equals to minus 1 by T, and which is of minus T. So CS is simply 1 over S minus T over ST plus 1. Convert it into this standard form. So take T common. So it is 1 over S plus 1 by T. Now taking the inverse Laplace, 1 minus e raised to power minus T by T and ut. This is my step response for the first order system, and going to consider the error signal. So before, just you can write the, or you can plot the step response. This is steady state value 1, and it goes to be something like this, right? So this is my step response for the first order system. Now ET can be written as RT minus CT. So RT is UT minus 1 minus e raised to power minus T by T and UT. So after solving this, you will get T. So this is my error signal. This is my error signal for the first order system with respect to the unit step. Now I am going to find the steady state error. Steady state error ESS, that is limit t approaches to infinity E of t, which is limit t approaches to infinity e raised to power minus T by T U of t, and you will get ESS is 0. So steady state error for this step response is 0. You can observe here, as t approaches to infinity, this response goes to the 1, and this is called steady state error. This is we call the steady state error, right? So this is my error signal, and this is my steady state error. So this is how we can calculate the first order system unit response. Now consider again the first order system, and I'm going to find unit ramp response. So RT is simply TUT. RT is simply TUT. So RS is 1 by S square. So Cs can be written as 1 by s square st plus 1. This can be partial fraction in this form, s square plus c st plus 1. And you, after solving a, b and c, the final response I'm going to write here. This is my ramp response for the first order system, and the error signal Et can be written as RT minus C of t, which is RT means TUT minus T minus T 1 minus e raised to power minus t by t, and this is actually completed E of t. So solving this, you will get t1 minus e raised to power minus t by t u of t. This is my error signal for the unit ramp input. And what about the steady state error? That is limit t approaches to infinity, and Et you will get t. This is my steady state error at t equals to infinity, which is a constant error, that is t. So this is how we are going to deal with the different of input to the first order system, and we observe the steady state error and the response for the different of input. Now the last but not the least, ये आपका एग्जाम में काफी बार पूछा जाता है, that is sinusoidal response for the first order system. For the first order system. Now for the first order system, I am going to draw a block diagram. This is my first order system, and I am going to apply a input a sine of omega naught t, sinusoidal input, and I will get a sinusoidal input with different amplitude, the same frequency, but the different of at different phase, right? So m can be given as the magnitude of this at input frequency. The magnitude, this can be written as 1 over j omega t plus 1. Magnitude of this value is omega t square plus 1 at input frequency. Input frequency is omega naught, right? So this is my m, and the phase of this system is minus tan inverse of omega t at omega equals to omega naught. So this is how we can calculate the sinusoidal response for the first order system. ये आपका many different of subject में पढ़ाया जाता है, आपका कंट्रोल सिस्टम में पढ़ाया जाता है, आपका नेटवर्क में पढ़ाया जाता है, आपका सिग्नल एंड सिस्टम में भी पढ़ाया जाता है. इज वेरी इंपॉर्टेंट और आपसे काफी बार पूछा जाता है इससे एग्जाम. 2-3 बार तो रिपीटेटिवली क्वेश्चंस आ चुके हैं इससे, राइट? सो दिस इज द फर्स्ट ऑर्डर सिस्टम, सिनेरियो ऑफ द फर्स्ट ऑर्डर सिस्टम, which is building block of the basic idea of the second order system, we can say. So this is how we deal with the first order system with different of inputs. ठीक है, नेक्स्ट लेक्चर्स में हम पढ़ेंगे सेकेंड ऑर्डर सिस्टम के डिफरेंट ऑफ इनपुट रेस्पॉन्स एंड व्हाट आर द स्पेसिफिकेशंस करस्पॉन्डिंग टू द डिफरेंट ऑफ इनपुट, राइट? ओके, सो सी यू.